Okay, hello. Today I'm going to take you through the creation of a halftone shader in Blender. So this shader essentially responds to the lighting in the scene. It runs off of the shadows and light already in the space. So for example, if we rotate the lighting here, you can see it's a dynamic shader. So I'll just talk you through how the shader works to start off with, and then show you how to create it. So the shader has a color output. By default it outputs as a black and white shader color. You can run that into an emission, and if you want to, for example, have a non-black and white output, you can run the output from the shader into a mix shader and then use emission shaders to basically change the color. So for example, if we want to add colored dots or color base layer, we can do that using this simple setup here. So essentially the shader has a number of values we can set here. We've got a Screentone balance, which essentially enables us to control the balance of the Screentone shader. At very low values, we get hardly any sort of white space, and at higher values it becomes almost pure white with just the shadows. We have dot scale. Dot scale basically changes the scale of the individual dots. So we can take this dot scale down. So we get very large dots, or we can take it very high to get a very fine mesh. Dot randomness basically determines how randomized the dots are. Set to 0, they appear in a very fine grid. By increasing the randomness, enables us to get a more random pattern basically. The roughness is basically used to control the reflective qualities of the object. Underpinning the shader is essentially a diffuse and glossy shader. So you can choose the extent to which your object reflects the background environment, etc. So if you've got environment lighting or lighting, you'll be able to use that to control how much it sort of responds to other objects and lighting. And the same with the IOR here, the index of refraction. So again, you can use that to control sort of the reflectiveness and the way the shader reflects other surfaces and the environment. The dot aspect ratio down here is essentially controls the squishiness of the dots. If I set the dot scale to quite low, you can see the dots can be quite squished, and so this dot aspect ratio basically enables you to get the dots looking right on the screen. So this is a value that you want to play around with, basically to get them to feel the right shape, but obviously you can play with these values if you want to go for other effects. Just set this back to 0.3. And the final thing is the color input. As I said, the shader actually outputs a black and white, but this enables you to add tonal variation through this color. So we can basically set this value here. So if you've got an object that has different tonal values on it, you can put an input here, or you can just define a color for yourself. So if you want to run an image texture in here, so you can put graphics textures, etc. on there. Let's just increase this dot scale so we get to a nice value. So that's the basic shader setup, and I'll talk you through how to create it now. So we're going to create a new shader. Let's give ourselves a bit more space here. We're going to delete principal BSDF. I'm going to start by creating the main driver of this, which is a Voronoi texture. So we're going to add in texture Voronoi. And the setup we want is 3D, smooth F1, and Minkowski. And if we run that into our surface, we get a basic Voronoi setup. What we're going to do here is we're going to turn down the randomness. And we're also going to increase the scale. So you can see already we're getting this kind of dotty pattern. But essentially what we want is for black dots, and at the moment you can sort of see we've got like these white cubes on here. So we're going to add in a converter color ramp. We're going to set it to constant, which enables us to get hard edges, and then we're going to swap the black and white values, which will invert the effect. You might need to adjust this to your own liking, but that essentially will create our dot pattern. Now at the moment, the Voronoi texture wraps around the object. What we want to do is to create this pattern, this effect, like you would see in a comic book, is to remap this so that it always maps onto the object as if it was on a 2D plane, like a surface. And the way we're going to do that is we're going to add in a texture coordinate and a mapping node. So we're going to go texture coordinate, and mapping. And what we want to do is take the window output from the texture coordinate, run that into the vector of the mapping node, and then run that mapping into the vector of the Voronoi texture. And now you can see, no matter how we look on the screen, this always faces towards us. Now the other thing we want to do in here is under the scale setting, we're going to basically change the Y value to around somewhere about 0.3, 0.4, just to get our dots exactly as we like them. 0.35, a little bit less. Stick with 0.3. Okay. So far so good. We've got a dot texture that sits on top of our object, but now what we want to do is control where this is applied to our object. So we want it to create larger dots where we have a shadow, and we want to create smaller dots or virtually non-existent dots where we've got highlights. And the way we're going to do that is we're going to set up a mix shader with diffuse and glossy. I'm just going to move the screen over here so we've got a bit more space. So we're going to start by adding in a shader, mix shader, and we're going to add in a diffuse and a glossy. Plug those both in, and we're also going to add in a Fresnel, which is going to enable us to just control that setup. So it's a very basic shader, just gives us sort of light and highlight, and as you can see we can change the roughness of the glossy shader to sort of reflect the backgrounds. Obviously there's not a lot to reflect in this scene, but you can see it will sort of respond to other objects within the space. Okay, so now what we want to do is basically take this output. We're going to ramp up the effect of the shadow and the highlight so that it gives us more control, and run that into the Voronoi. So we're going to add in shader to RGB. Shader to RGB is then going to be run into a color ramp. And using this, we can slightly squish those values so we can get darker shadows. We can also use it to push the highlights. So this gives us some fine control over the actual effect sort of under the hood of this shader. Okay, now what we want to do is take this color output and run it into the exponent aspect of the Voronoi texture, which over here basically controls the dot size. So in order to do that, we're going to run this out. We need to basically take that value, and the way we're going to do that is by adding a separate HSV node. So what we do now is we take the output, the color output from the color ramp, plug that in. Now if we look at the HSV node, we've got the hue, saturation and value, and the value is the output that we want because it essentially controls this shading here. In order to get a useful output from that, in order to run it into the exponent, we're going to just add in a map range. This also enables us to have some control of this outside of the node once we've grouped all of these nodes together. So we're going to go here, we're going to look for map range. Okay, and what we want to do is plug the value in at the top here and take the result out, plug it into the exponent of our Voronoi. And now plug all this back in, plug our color ramp back in, etc. Everything's sorted. So now this 2 max at the bottom here enables us to control the distribution of our screen tone. We're going to turn off clamp. That will enable us just to have a bit more fun with these settings here. And that is essentially our setup. And if we just test now, if we rotate our sunlight, we should be able to see. Let's try that again. Our shader responding to the lighting within the scene. Okay, so now what we want to do is essentially take all of these nodes, let's just squish them together a bit so it's a bit easier to work with. We're going to group them all together so that we can then create a single shader from it. So we're going to select all of those objects, Control G to group. And now what we need to do is define the inputs for this object. So we're going to start off with our map range to max input here. We're going to plug that into the group input over here on the left. We want to take the halftone scale. So we're going to take the scale input from the Voronoi and plug it into our group input. We're then going to create input our randomness input. Plug that in. We're going to take the roughness from our glossy and the IOR from the Fresnel. We're going to take the normals from our Fresnel, our diffuse and our glossy and plug those in to that same normal node. We're going to take from our mapping node our scale in case we want to change the dot aspect ratio, and we're also going to take the color input from the diffuse so that we have that fine control over the texture and plug that in. And now what we want to do is just check some of our values. So the to max setting here, we're going to change to screen. Let's try that again. Screentone balance. I'm going to set the minimum value here to 0. I find a value of around 3 is probably good. And we're going to set this to 2. We're going to choose our scale. Again, we're going to set the minimum to 0, but we can leave the scale at 1000. I'm going to set the actual default value to 200. Randomness, again, we can leave that. I find a default value of around, a max value of around 0.2 is quite good. Roughness we can leave as it is. IOR we can leave as it is, although default around 1.45 is good. Normal. We're going to change the name of this scale to dot aspect ratio, and color we can leave as it is. So now we can tab back out, go and look at our new shader. So as I said, we can now play with Screentone balance, our dot scale, the randomness, etc. And there we go, Screentone shader. As I said, the nice thing about the shader is it will interact in the scene, it will create dynamic shadows and receive dynamic shadows from other objects. And has a number of different applications. As I said, playing with things like using it as a factor to create different colors. You can obviously create more interesting inputs. You can create gradients in these colors. You can also play with this dot aspect ratio to get some other really interesting effects. There you go, that's it. Have fun.